So we ended the part one with this slide right here and you writing your hypothesis. Let's talk for just a moment about this experiment. Each block has inertia. Everything has inertia. It's wanting to stay put. It doesn't want to move, and if it is moving, it wants to stay moving. So if a force acts only on the bottom block, the block will move in the direction of the force. So if I hit the block this way, the block will go that way. The inertia of the other blocks will keep them in place. So this relates back to the tablecloth trick video I showed you, where the man took the tablecloth and he pulled downward on it. And when he did, the cups and plates and silverware all wanted to stay where they were. They wanted to stay in place because they had inertia. And by pulling that out from under them, they wanted to stay put, and the tablecloth was able to slide out from under them. So as you can see, the block will slide out and the others will come just straight down, or should, unless we hit it wrong, and then we can make a mess. All right, so then this is on page 15 at the top. When the forces on an object are balanced, that means that they're equal, the net force is 0, and there is no change in the object's motion. We're not going to be getting into all the net forces and newtons and all of that. Now we're going to be talking about Isaac Newton, but we're not going to be getting into the measurement of Newton. So you don't worry about that. If you see it written somewhere or in something, just know that it is a type of measurement, just like Celsius and Fahrenheit are types of measurements for temperature, pounds and ounces and grams for weight. Newton is for force, and that's what the N stands for right here. So let's go right on. So when an unbalanced force acts on an object, the object moves, sorry for the typo, wasn't me, in the direction of the net force. So unbalanced forces cause movement, and balanced forces cause no movement. So think about maybe you and a friend playing. If you're near the same size, strength, weight, and you're pushing on each other, neither one moves. But we have a much bigger friend and a smaller friend pushing, and it's going to cause movement. And so at the bottom of page 15, you can see I put a big X over that chart, and I would like for you to do the same. I'm not having you measure in newtons and finding net forces and all of that stuff. No. So right now, what I want you to do is you're going to get out your teacher-made packet, and I want you to turn to page 16. So on page 16 of the teacher-made packet, you see right here, this is a braking system. This complicated system in a car brakes, this is a complicated system in a car brake system. Miss Fleming can't read this evening. When you press your brake, it puts force on the brake lining, creating friction and slowing down the car. So when you push on the pedal, then it is going to cause inside of here, it's going to cause brake fluid to push back through here and down. And right here, do you see this little gap, the little yellow gap right there? Do you see that it is greater right here? It's larger. So the brake fluid is pushed, and it's pushed down into this little area. And when it's pushed into this area, it forces these black pieces right here outward because there's more fluid being put into that little tube between them. This little round part between them right here, it causes more fluid to come in here and then pushes the two black pieces outward. And when it pushes the black pieces outward, it pushes these gray parts right here outward and pushes in the black part into the side of it. So you have the brake lining right here and the brake drum. And so when it pushes it out, it slows it down. I know that you've heard your parents possibly talk about rotors and brake pads before. This is what this is. This is what wears down. So like the black part that's called the brake lining on here, that would be your brake pads. And please, if I'm wrong, an adult correct me, but this is the gray part would be like your rotors. And sometimes you may hear your parents talk and they may say, well, the brake pads need to be changed. It's not into the rotors yet, but they're pretty low. Well, that's what all this is talking about, is that braking system. Alrighty. So right here, don't slip on the ice. As you see at the bottom of page 16, it says Video Magic School Bus Plays Ball. I am not going to show you that within this video. So what I'm going to do is I will post the link for the video under this on Google Classroom. So I would like for you to pause the video now and go watch Magic School Bus Plays Ball, and then you have some questions to answer on there, okay? I'll just put it with the questions, but you can pause now and go to it. Forgive me, it will be under the link for this video on Google Classroom. It would not let me link it under the assignment. All right, so if you look in your lovely, lovely booklet right here, on page 16, you see observing forces. You see this activity right here, and it's going to take up both pages. You're going to have balloon, tape, tennis ball, ping pong ball, golf ball, ruler, balloon, paperclip, straw, rubber band, tape, index card. You will find the materials listed under materials at the top of each page. You are going to complete this activity on pages 16 and 17. And then I would like, if you are able to be able to do this activity. I think it'd be really fun for you. You are, I was hoping to get to make a video, but the way this week has been, I'm not getting to. I'm very, very sorry. So if you get to, post it on to, post pictures and stuff onto Google Classroom. Let us see. If you make a video, please share. I think it would be really neat and really fun to do. And if you do it, you do not have to take all the measurements. I won't require that. If you want to, great. Just to be able to tell how far it went. But I think it would be fun for you to do with family. All right, and so this is the end of part 2. I hope you enjoy your experiments. I want you to have fun with it. Science isn't supposed to be boring. It's supposed to be fun. Explore, question, wonder, get out, try new things with force and motion. But remember, it's not the landing that hurts. It's the friction. Bye, kiddos.